you go from that? How do you figure that? How does that wireless happening? What's going on here? That's a NST, 15,000 volts, 60 milliamp, 7 beer bottles for capacitance, salt water with oil on top, conductor rod running down the middle. They're all connected through the top. The NST is oscillating 60 hertz times a second. It's filling up these capacitors. And also these capacitors are in resonance with the inductor. The NST, if you look at it, it's an iron core with wire wrapped around it, and that is a inductor, and that inductor will determine how big and small the electromagnetic field will be coming through here. That's how they get to that 60 milliamps, kind of range it. So let's bounce out of this wild craziness, but wireless. And let's, oh, broken glass. Can't keep that one. But I don't want the dog stepping on it. Not good to hurt the doggy's feet. All right, let's come over here. We'll talk about the components that we have in that tester coil, and we'll do them in ways that we can utilize our technology today with transistors and capacitors and resistors, LEDs, transistors, air capacitors, conductor plates, potentiometers, electric motors, inductors. That's a toroid inductor. And we'll start off with that since we were just talking about induction. Inductors, that NST. What we have here is I got one car battery, 12 volts coming into my breadboard. I got two 2.7 volt LEDs with 12 volts coming in to burn them out. So if you put resistance on one side, it doesn't matter what side, it could be either side, but off the hot or the cold, put resistance in there, hot or cold. Listen to me. You would allow that bulb not to burn out so you can use them. Coming out of here, we're jumping and feeding the positive and negative over to this breadboard. On this breadboard here, I got a 555 timer oscillator chip, and that oscillator chip is controlled by the speed of it. The speed is controlled of that oscillator chip by the capacitor that I have in the circuit right there. And these are resistors, and they are literally this resistor here. If you pull that off, you can put the potentiometer there. And here's my potentiometer, and I got two prongs coming off. You just use the one to the left and one in the middle, and you can adjust the speed of the limits of the values of what that is right there. But we want to get into the inductor part, wireless part. How I wanted to share with you guys how I've learned in the last 4 years on different things. It all started from Ed Lee Scowen, which you can see his wheel over there. Ed Lee Scowen has taken me into learning about all different kinds of things related to electromagnetism. That's all magnets, north, south, running around that wheel. But right now we're working on sharing a little wireless knowledge here. So these are two capacitive plates. These are two air capacitors. Um, One, this set here and that set there of the plates up top are being fed from two different transistors. These are 2N3055, and these are in series. Well, no, they are in phase, but they're um, they're in phase, but the poles are the opposite here. And how I can find that out is when I put my LED up to this, you'll see it light, and then I come over here, it won't. So I literally have to turn the LED over and come over here and the LED lights up. So that tells me that two poles are set up here. And so we have created with the circuit is a dipole wireless system. I know it doesn't sound like a big deal, but there's a lot of components here to learn about and how to stretch out the wireless capabilities in the field. Like Mr. Tesla over there, um, these components over there are barbaric in today's standards, but they get the point out there that there is wireless. You can send it. You just need to organize it. So let's go back over here. I'm going to go ahead and turn this light off. And let's go ahead and we have the smallest capacitor right now. So these lights here um, will light up based on the speed of this capacitor to these lights. One thing I want to do is bring in a compass, and we're going to put a compass on top of this inductor, because remember this inductor is filled its field and collapsing on the command of this transistor up top. So we're going to see movement there, and where she sits right now, that's natural north on our planet, and we'll watch and see how she's pulled. Let's go ahead and fire it up. All right. So you can see the LEDs are on. You most likely can't even see that they're flashing, okay? Because they're flashing pretty fast. Let's turn it off. Let's watch the compass move back to original north, and you'll see that the compass will move to that magnetic field that it is sitting on top of, okay? Let's create it in that toroid. Turn it off, and you'll see it's collapsed. All right, so that's what is going on with the inductor. Now let's start off and let's do this. Let's kick it on. All right, and let's grab our LED. Now this LED, let's see if it lights up. LED lit. LED lit. Now remember, that plate's not touching that plate, okay? Now that's running off of this transistor. Okay, now this transistor over here, I come over here and it won't go on. It won't go on. So I gotta rotate my sides. And remember, this LED is a it's a dioid. So we're gonna come over here now, and you'll see the LED just lit up. Over here, the LED a little weaker, but it's lit. Okay. So I want to show you how important the induction is of the inductor. So now we're going to go ahead and turn it off. We're going to unplug the positive out of the inductor. So when I click this on, the inductor does not move. The compass does not move. Still got the same speed, flash, and everything. All right, so let's go ahead and really, well, there you go. Let's go ahead and come over here and check out this. Not on. Not on. Not on. Not on. So it takes the magnetic field to build up more energy in the inductor. And what we see here is that in the inductor, there is a subsequential rate of change, a rate of current change, okay? And that's obviously determined by the speed of that capacitor. So let's go ahead and take this capacitor out. And let's go ahead and put in Mr. Big Guy. Now, what I would expect to see with Mr. Big Guy is that we'll see the compass. We'll see the compass pull, and then we'll see the light go on, and then we'll see the compass break, and you'll see a slow pulse because I got the big. Oh, darn it. I'm wondering why it's not moving. Staring at it. I got to plug in. We just had the inductor off. So let's plug it in now, and bam, you'll see it pull. And you can see that now it's collapsing. I'll back on. Collapsing. Back on. Collapsing. Back on. Collapsing. So that's the field, and that is the rate of change. And, you know, I want you guys to check out something called Kirchhoff's rule, and it's an equation that, a mathematical equation that you could use to figure out how much inductance you want in your circuit. Because obviously we just seen that, get my light again, we just seen that the inductor caused light to come on out here in wireless, and it's not right now, and we have a bigger capacitor in there. So we're going to go into the next part of this learning lesson that I have, my journeys.